install the rest of the parts, solder and shorten the leads. Okay, so all the parts look like they're labelled with their values on here, which is quite nice. So let's see what we got on here. We got inductor, big TO220 transistor there, switches. So I think we'll go for resistors next. They look like they're the next lowest part. So 150 ohms. Looks like that goes in here. Next, 10k. Any more resistors? Yes, there we go. A couple of 100 ohms. So there's not too many parts to this at all, so I think it's a relatively simple kit to put together. So that says 100 there, I'll go for that one. And the one, oh, interestingly, there's 3 positions for 100, but on the diagram that one's not populated. So I guess we leave that one out for now. Yeah, this one's much tighter cropping on the legs. Okay, is that it for resistors? I think so. So we'll solder those in. It's a bit wonky and not really centered, but there we go. Price we pay for rushing. Now it does say 470 there. So where's my 470R resistor? There it is. I missed it. There is one. So a lot of the Nixie clock kits you can buy are 6-digit clocks, so they show the seconds as well, but I've always kind of wondered why people want to know what time is to the second. I suppose if you're building the clock as a sort of art piece, then it's nice that it's dynamic all the time. You know, there's always something changing on the screen. But yeah, if it's for a practical purpose or a combination of the two, then yeah, I can't help thinking it can be a distraction. So again, this is only a 4-digit clock, which I quite like, and hopefully the person I'm building it for will quite like that. Shorten the IC legs there that I forgot to do. Okay, so what parts have we got now? We've got the diode, ceramic capacitor, we've got a potentiometer, and then we're getting on to slightly more bulky stuff. So let's go with the diode. So there's quite a tight space on there, so I'll put the band way around. So this looks like the high voltage supply for the Nixie tubes. There's no dedicated IC or anything for it, so I'm guessing it's also controlled by the Arduino. It may be that actually, if there's no digit planking on this clock, then it may be a simple open loop boost converter using an inductor and a MOSFET switch. With no modulation of the PWM at all. It may just be running at a fixed duty cycle, because the load current on a Nixie tube clock is constant if you always have the digits lit. I know that it does have a night mode, which I think dims the tubes, but that might just be a global change in the PWM, because all you need is less current. So it kind of makes sense that it will be a very simple design, and I quite like that. It makes it quite elegant. It's ultra simple. Very little to go wrong. There's no chance of any squealing from the inductor if there's no closed loop control of the voltage, because, well, there's no feedback loop to oscillate, so you've just got literally the switching of the MOSFET itself, which is going to be outside the audible range, I'm sure. Or at least I would hope so. So yeah, That'll be interesting. Not sure what this preset's for though. That is part of the... It does look like it's coming from the high voltage cap, so maybe there is some feedback on that preset. Maybe the Arduino has got an ADC in it. So I'm not overly familiar with the Arduino, so I'm fairly sure that some of them have ADCs in. Maybe he's using an ADC to control the voltage that way. So anyway, time will tell. So we've got a ceramic cap here. Value of which is... It's 105. So is that 1 microfarad? No, I can't. Oh, there it goes. It's right next to that IC there. So let's put that in there. Big copper plane on that pin, so it's a bit hard to get the heat into it. So high voltage capacitor is the next step, so we'll leave that out, which is, that's low voltage. Here's the high voltage capacitor, so I think the MOSFET's probably one of the next things to go on. So what we've got here, we've got an IRF 830. So it's going to be folded over, so I'll try and keep my fingers on all the pins simultaneously so I don't have too much risk of getting a static problem with this device. So I'll bend the legs over, pop it in there. It looks like it's going to clash with the switches if I do it like that, so it looks like I need to bend the pins quite a bit closer. I don't really like bending the pins that close to the package because it always feels like you're going to snap the pins off or damage them in some way. So there we go, that's better. Okay. Well. Okay, so what we're missing, we've got some connectors, another capacitor to put on, so we've put this capacitor on now. 470 mic, 6.3 volts. So over here, still on that side. There we go. Okay, looks like the inductor is probably one of the next smallest parts. 220 microhenry mounted. Okay, so we need to preform the leads a little bit here. So we'll spread them out from the body. Something like that. Yeah, not bad at all. So I don't know if you can see that, but on the back it says Nixie Clock version 2.2 by Alex Guyver. Based on IT Work Club PCB. Not sure I know what any of those are, but there we go. So I think we've got all the parts now, all the small electronic parts in place. So install high voltage capacitor seems to be the next step, and that's on the rear of the unit. So let's get this out. negative at the top there. Again, it's right close to the package. So like that. So that's a 4.7 mic, 350 volts. It's sitting on one of the soldered through legs there, so I'm just going to make absolutely sure that's nicely cropped off, which it is. And I'm going to bring it this way a little bit because the picture shows it kind of not near that leg, so I'll bring it across and see if we can get a bit more like the picture. There we go. Yeah, that's clear now. Okay, the voltage capacitor is in. So now it says we've got to solder 2 wires for the power connector. So is any wire included with the kit? It would appear not. Let's just empty out this one here, see what we've got in here. Battery, switches, mechanical assembly parts, and connectors. Okay, so we need some wire. So bring out some of the old rack electronics. 7.2, bit of red and black there. So these are going to solder into the PCB, so don't need to strip much off. Alright, some wire on there. Install the RTC module. So that gives the game away, doesn't it? It's a real-time clock module. Go in here. Looks like there's some options on this board for maybe a different type of module as well. RTC Mini. So is there anything going to keep the spacing of this? Doesn't look like there's anything that can short. So let's just put one pin in and see what it looks like. Okay, slightly skewy, so I'm going to just add a fraction like that. Okay, looks good. Right. Good. Okay, RTC is in place. Trim these wires off, forgot to do that. There we go. Install and solder 3 buttons and power connector. Buttons go on the same side as the RTC. Okay, they didn't actually hold themselves in position terribly well, so I think I'll do one at a time, just make sure they're in properly. Just solder diagonals and then press home. Good. Okay. They all ought to be lining up pretty well. So that click you just heard was my automatic timer on my soldering iron, so I'm just going to restart the soldering iron. When you get to my age, you often forget to turn your soldering iron off, so I have I think it's like a 30-minute or 15-minute timer on the power supply to it, just to make sure I can't leave it on by mistake for any length of time. It's just a plug in the wall socket thing made by Energini. It's really quite useful though as a safety feature. Okay, so we need to connect up the DC jack, but it doesn't really say which wire goes to which pin. The socket doesn't look quite the same either, so I think the safe option here is to check what we've got. So we'll bring in a power bank. Plug this in here. So it looks like that's the centre pin, which I'm assuming is going to be positive, and then one of these others is going to be ground. So let's turn on. I think this is positive. Let's compare to this one. Nothing. There we go. 5 volts. Power bank's just gone off because there's no load, but that means we don't need this pin. And positive is the centre, so that's easy to remember. So it looks like we don't need much in the way of length here, so if I put this down here, it looks like this is going here. To here, kind of like that. So it's nothing wrong with guessing, I guess. I'll go with that. I should twist this way, really. For some reason, the way I've always twisted wires all my life is the opposite way to what they're normally manufactured at, so I end up untwisting the wire first and then twisting it in the opposite direction a little bit. I should have just got used to twisting it the right way, but there we go. So let's just twist these together a little bit. Hopefully that won't make anything awkward. Bring in the helping hands for this bit, because it's going to make things so much easier. Put that on there, so we'll do that first. These old helping hands I've had for I don't know how many years. I think they were bought from Tandy, probably back in the 80s. And yeah, they're getting a little bit worse for wear, but they're still going strong. Yeah, they're a little bit, sometimes get a little bit loose, but doing really well. Can't complain about value for money for those. Alrighty, install and solder small connectors on the board. Put the socket pins on the lamp terminals. So I think what that's saying is put the pins on the main board and put the sockets on the lamp board. So which way around? It's going to want to be on the other side, isn't it? Which way around is this way? That's good, the board's still not got too much height on it, we can still hold those pins in place. So I'll just check that for angle, it's slightly out, isn't it? There we go. Looks good now. Given there's only one driver chip on this PCB, I'm guessing that it's a multiplex display and it's going to be a 1 in 4 multiplex. And I think these optos are probably what's driving the anodes of the Nixie tubes. So it's quite an interesting approach. But given they're multiplexed, I'm wondering how bright they're actually going to end up being. I'm not really sure how much you can overrun a Nixie tube if you're multiplexing it. So with LEDs it's quite common to use a higher current when you're multiplexing to give you the same effective brightness, even though it's on for, well, in this case, 1/4 of the time. But I don't know whether Nixie tubes you can do the same sort of thing, because the cathode poisoning problem presumably gets worse very, very quickly if you increase the current. So it'll be interesting to see how bright it looks when it's all complete. So that's that one in. Let's put the other one in. That's very much, I think. Okay, so that's what it's looking like at the moment. Two header pins, two sets of header pins. Hopefully that's focusing for you. So that's what one side looks like, and the other side.